On May 23rd, DeepSeek permanently locked in a 75% price cut for its flagship AI model. A million output tokens now cost only 87 cents. To put that in perspective, the equivalent model from OpenAI costs $30 for that same volume of work. DeepSeek is now 34 times cheaper than the industry standard. We are watching the cost of artificial intelligence fall away. Digital thought is moving from a premium luxury toward a commoditized utility. We can see the scale of this collapse in the new $200 million partnership between Anthropic and the Gates Foundation. They are deploying frontier-class models into regions where basic health and education services are often out of reach. In global healthcare, Claude is being used to accelerate vaccine development and provide diagnostic support for conditions like preeclampsia in rural clinics. The deployment also reaches 2 billion people who depend on small-scale farming, providing specialized agricultural guidance to increase crop yields. Frontier labs are prioritizing market share over immediate profit, treating digital intelligence as an abundant, nearly free resource. This creates a massive paradox. If the thoughts themselves are becoming free, why is the physical industry behind them demanding such a staggering, escalating investment? To find the answer, we have to look past the abstract data grids and move down into the physical reality of the silicon chip itself. While the mind of the AI is becoming boundless and cheap, its physical body is trapped in an environment of extreme material costs. Big tech companies are committing $700 billion to physical infrastructure this year, nearly double what they spent just 12 months ago. 2/3 of Microsoft's quarterly spend buys hardware with a brutal expiration date. These GPUs and CPUs fully depreciate in just 3 to 5 years, requiring a total cycle of replacement that traditional infrastructure never faces. Viewing AI tokens as manufactured goods reveals their true nature. They are physical products bound by factory capacity and rigid supply chains. It is a common myth that the AI processor, the brain of the chip, is the primary driver of these costs. In reality, the process and logic only accounts for about 13% of the component spend. The true bottleneck is high bandwidth memory. This specialized memory sits beside the processor, acting as a physical parasite, consuming both surface area and budget. Memory components now consume 63% of every AI chip's cost, up from just 52%. These physical limitations create a gap between how AI performs in a clean, lab-controlled demo and how it acts in the messy, real world. Researchers call this constraint decay. When AI agents leave sterile test environments and face real-world back-end databases and rigid frameworks, their performance drops 30 points as they struggle with the structural rules of production code. This 30-point failure rate suggests the gap between idealized intelligence and functional production is much wider than the marketing benchmarks claim. The hidden cost of cheap AI often takes the form of digital pollution. Open source communities are currently overwhelmed by a flood of hallucinated bug reports and fake reproduction steps generated by low-cost models. This flood effectively transfers the cost of cheap intelligence onto the human maintainers, who must volunteer their time to clean up the noise. Engineers are now deploying radical solutions to bypass these hardware and software bottlenecks. They are moving away from the expensive frameworks typically used to coordinate AI agents. Instead, they are developing subterranean agents, where the complex workflow logic is baked directly into the model's weights. This removes the need for the model to use its memory to reread its instructions in every single message. By internalizing the workflow, these models eliminate the massive consumption of context window space and the latency of external orchestration. In complex travel or insurance scenarios, this approach matches the quality of massive agent chains at a 1/100th of the operational cost. Another breakthrough attacks the memory crisis by aggressively starving the models through ternary quantization. By forcing the AI to calculate using only 3 states, -1, 0, and +1, engineers slash memory and energy requirements, maintaining high performance. This extreme mathematical compression decouples enterprise-grade intelligence from trillion-dollar data centers, allowing frontier-class models to run on consumer hardware. We are entering a future defined by 2 extremes: The massive $700 billion industrial AI factories on one side, and highly compressed, nearly free models living on our personal devices on the other. The physical machinery required to train these models will remain the most expensive infrastructure in human history, but the digital thoughts they produce will live everywhere for almost nothing. As the heavy infrastructure of the physical world fades, only the weightless digital spark remains.